thanks a lot. It's more than a pleasure. It's an honor to be with you all tonight, although I have no clue who is around, but that the beauty of the teletransmission of information that we have now. The idea would be to present to you how things started more than 50 years ago, or 60 years ago, actually, in Soviet Union, because actually, as I will just tell you, it was really the very beginning of that, and I think we are, yeah. So for whatever reason, I do not know why, but I cannot, here it is. Okay, so the only people I will talk about is this guy, Mr. Sergei Korolev, who was the chief engineer of all the astronautics in Soviet Union, studying even during the war. And he built all what happened to be the Soviet program, starting with the Sputnik, as you know, and the Sputnik, which was launched October 4, 57, was of course well known everywhere, the famous beep beep. It's interesting, we have no time to discuss that today, but to realize that at that time, the mere fact that we had the possibility to put an object in orbit around the Earth, something like 200 kilometers, no more than that, was so new that the very first thing we had to demonstrate, or they had to demonstrate actually, was that we could communicate. There was an emitter, the famous beep beep was received on the Earth, and that was used to say, well, in that case, we can really transmit information from the out of the atmosphere down to the Earth. And so that really opened the space era, as we say now. But what I want to emphasize here is that no more than a year later, the Soviets did a new premiere, which was to say, well, if we are capable of sending an orbit at an object at 8 kilometers a second, which is the velocity required to stay in orbit around the Earth, let's push a little bit, and instead of 8, let's go to more than 11 kilometers a second. And most of the people, everyone, I guess, know that with that energy, you have a kinetic energy sufficient to leave the Earth's gravity. And they decided to test that, to guess their capability to send a probe at that velocity. They had to target something, and they said, well, let's target the, not necessarily the easiest, but the closest object, and that was the moon. So finally, January 2nd, 59, they launched the very first extraterrestrial, we could say, vehicle out of Earth, and that was Luna 1. And really, Luna 1 opened a new era here because it opened the capability to go out of the Earth toward the interplanetary space. And first, of course, it's been used to go to the other planets, and we are still there now. So frankly speaking, when we are asking for what is the real origin or the birth of the space exploration, that's really what it was. Space exploration really was born January 2nd, thanks to a lunar mission sent by the Soviets there. The Americans that were the other country capable of doing that, or almost capable of doing that, did that much later on. So that was, but that's not the purpose of the discussion today, a new enigma that the Western countries had to solve, how the country supposed to be in the Middle Age could be the first to send such a beautiful spacecraft in space, and that's been demonstrated afterwards. So what we should remember really that the solar system space exploration started January 2nd, 59. It's not that long ago. It's really almost only 60 years. People of my generation saw that it's really our generation, and it's important for the young generation today to realize that space exploration is really something which is of the same age that people like me are. So we really are in the first era, first age of space exploration. So there has been a lot of things, and I like stamps, and so that's why I showed what has been emphasized at that point. But again, let's remember that space exploration started there. Of course, as soon as they had the capability to send probe over there, it was not only a technical achievement, it was also a scientific achievement. The scientists immediately tried to use these as new capabilities to make measurements of things that they could not do on them, that we cannot do on the Earth. And actually, because spacecraft was to get out of not only of the Earth, but atmosphere, but the magnetosphere of the Earth, which, as you know, protected us against what comes from the sun. They said, well, let's measure something there. And of course, that it's almost history now, but through the observation of the cometary tails, the idea was that possibly to explain the tails, you had to hypothesis that the sun does not only emit radiation, like the solar radiation, but also particles. And the existence of the solar wind has been proposed as just to interpret what people saw out of the comet themselves. That was in 1953. And rapidly, the people, the theorists, tried to understand how the sun could expand the corona, actually, the corona, which is not steadily around the sun, but is dynamically expanded out of the sun. And that's why we call that a wind, a solar wind. How could that fill the space? And the Soviets realized that getting out of the magnetosphere, which protects us against the solar wind, supposedly it exists, when getting out of the magnetosphere, we could measure, characterize the solar winds. And the first probe sent to the moon had, as you can see here, had some ways to measure things. And what has been measured is really the plasma out of the magnetosphere, which come from the sun directly. So it's important to realize that not only they demonstrate that we have the capability to get out of the Earth's gravity, but we also can do things like measuring space out of the what is accessible from the Earth. And rapidly they did two more missions during the same year, 59. The Luna 2, Luna 2 was supposed to drop something on the lunar surface, and of course they put the flag in the sort of the ball that you see here, and that was the first time man put something made by himself on another body, and that's an impact, a man-made impact on the moon. But I think the most important is probably what they did in not September here, but in October, really. In October, they decided not only to go to the moon, but to go just out of the moon, and to get out of the moon at a distance so that the satellite would become a satellite of the moon itself, and so it would go around the moon. And getting around the moon, it would go on the far side of the moon. Of course, we have no time here to discuss and explain why the moon always show the same side to the Earth. It's just a tidal effect, which is sort of well known now. But because of that, we have no way to know what the far side is. And they decided to get on the other side of the moon. So that was absolutely splendid technologically, but of course it was also very important scientifically, because then they could say, well, we will explore something that we cannot have access to from the Earth. So in other words, space became a way to observe what is not observable. You can observe the invisible just by sending probes over there. And they did that. But of course, if you did that, they have to take pictures. And to take pictures, normally you take a picture and then you take the plate back here and you make the processing of it in the lab. They didn't have the capability, of course, to retrieve the picture themselves. So they had to transform the pictures into waves. And for the first time they did that in 6 months. It's amazing. They built something to be able to make this picture. We'll go back to the picture, but first I want to show how they did that. They did a real picture with a real Zenith type camera. And on board, they automatically process to make the silver concrete, as we do in the Polaroid, actually here. And then with an electron beam from an electron filament, they go through the silver and try to transform the density of the silver into a signal, transform into a wave sent to the Earth. And when the process back has been done here, that gave the image that you have here on the left side. And that was really tremendous because, of course, now compared to the images that we have from the moon, it looks, rough. But it was very, very important. Why? Because they said, well, instead of just measuring the far side, they decide that what we see on the left part of the picture to take also a fraction of the near side when we know that there is both mare and continents over there. And the few mare that we see on the left side were taken here essentially because they said, if we do not see anything on the image, we will never know whether there was nothing to be imaged or whether our system did not work. So then at least we had the capability to verify that the image is correct in the sense that the mare on the near side is visible. And what they observed that on the far side, which is the right part of the image, there are essentially, no mare at all. And of course, this discrepancy, here you see something which has been taken much later on, 60 years later, 50 years later, by a splendid probe, when you can really compare what the first image was on the left and what we have now from space onto the surface of the moon. And of course, it posed the question why we have so few mare on the far side. It's not time now to discuss that, but that's very interesting because that directly translates something within the interior of the moon, which has to do with the presence of the Earth, but it's not so trivial really to explain that actually. So it was the first not only demonstration that space can observe something which is not observable, but also pose questions that we didn't have even idea of before, and that entered the sort of thing, the answers given finally, they are something very fundamental about how the moon was formed, how it is now, and what the effect on the Earth to the moon and on the moon to the Earth. So that was in these dates. And very soon afterwards, because that was in 59, but some 10 years later, they decided not only to send automated landers or orbital landers, but even rovers on the moon. And it was the first time ever that a rover was sent on another body in the solar system. And these rovers were very spectacular because, as you can see here, they could really go tens of kilometers automatically by themselves, guide from the Earth, of course, but they could automatically transverse there. And this is a sort of track that they have here. And looking at the scale, you see that typically the scales give you the entire bar is 4 kilometers. So you saw that in these, and they did that several times, they could traverse tens of kilometers there. And not only they could traverse and measure things, but that's important that they make the real measurement there. And what the measurements were, essentially, it was the composition. For the first time, they brought over there X-ray spectrometer, which were capable of analyzing the elements on the surface, like silicon, aluminum, calcium, iron, manganese, and so on. And by the ratio of them, and by the variation of this ratio, they could, for the first time, analyze what the Apollo missions could do from orbit, essentially, which is the difference in composition between mare minerals, mare materials, and the continental highlands, as we say, which are the highlands depleted in iron and the mare enriched in calcium and iron. So lots of things have been done in these times around the 70s, which is exactly the time during which we had the Apollo program. And of course, the Apollo program was so spectacular and fundamental that no one really talked about these, which were done robotically. And as you will see in a second, that's very important for what happened at that time, but also for the future. And of course, if you have measurements, you have to transmit them to the Earth. And it was really the cover of the rover that was used as the antenna, more than 2 meters diameter antenna to the Earth. And so all the X-ray measurements robotically observed and obtained were transmitted also robotically to the Earth. And that has been done 2 times. And then, and I will finish by that, because that's really probably the most important part of these early Soviet missions, they decided to go to the moon, to land on the moon, and to collect samples and automatically collect them, bring them back to the Earth, and retrieve them in the Kazakhstan. So the way they did that 3 times, it was Luna 16, 20, and 24. Luna 16 that you see here, it's not the pictures which have been taken there, it's really a mock-up which has been measured, or pictures before they were sent or afterwards, or even paint. And as you will see, I like the paints because the paints has been made by Leonov, which was one of the first cosmonauts. Unfortunately, he died a few months ago. And he was the first to get out of his Vostok, actually. That's what we call that, the first man who went outside his capsule. And he's also a painter. So he made many, many pictures like that and painted also. And what you see here is on the left part, what has been used to collect the samples, to bring with the arm back to the small bull that you see on the top of that. And you see that on the top, you have the entire capsule that has been automatically fired. Not the entire spacecraft went, but only the top here with a rounded capsule and what is below that with the gas and everything there. And that has been automatically fired, launched, initiated up to the moon Earth trajectory and back to the Earth through the atmosphere in Kazakhstan and retrieved, and all the samples have been retrieved. It's amazing that in the early 70s, they could do that. Remember that at that time, space exploration had only 10 years. It was really the birth of that, and they had already this capability. And this is typically how they collected the bull that you see here with the samples in the big tube that you see here. That was for Luna 20. And Luna 20 was done at a time, it was in 72. And as you know, the Apollo program completed in 72. So we had hundreds of kilograms of samples from the states that we analyzed. And something that has been observed is that because of the cratering of the surface of the regolith, as we say, which pile up different, each time you have an impact, it puts on another their level of material. So now, if you take a sample which is, let's say, deep inside, like half a meter or more within the surface, this sample was on the surface long ago. And typically, you have typically 1 billion years per meter. So if you collect a sample which is now typically 1 meter below the surface, it was on the surface 1 billion years ago. And what they decided, which is really amazing, is to drill a core of 3 meters. And you have here on the left drawing also, or picture of a mock-up put on a drawing here of Luna 24, which was launched in 76, with the core drilling system on the left side, which is very interesting because it could go down to 3 meters. Well, 3 meters long, which because of the angle, collect typically 2.4 meter deep in the regolith. And of course, what they want is not only to take samples at that depth, they wanted to keep the entire core back to the Earth. And of course, you don't have the capability to put a core of 3 meters in the atmosphere back to the Earth, in the atmosphere of the Earth at this velocity. So they invent the system that you can see on the top of the drill that they have here, which is a way to separate the steel that they use to core. When they take the core back here, there is a Teflon tube that captures the entire core and then round it like a snail in the ball that you have up there. And this is transported back to the Earth. And when they got that in 76, after they retrieve the entire sample, they could deploy it and retrieve the entire core with a resolution of a few millimeters, which translates into a few million years in terms of when the samples was at the surface. And when we had the possibility to analyze the samples at different depths, we had the capability to retrieve the characteristic of the interplanetary medium, in particular of the solar wind properties, over several billion years. And that's how, for the first time, we could in particular retrieve the variation of the intensity of the solar wind in terms of energy, and that's directly connected to the way the sun evolved in the past. So that's also just to give you an idea of what we could do with that sort of missions. Of course, most of the core of that was that they retrieve. Here you have, I like these because on the left side, you have a Leonov drawing of the Luna 24, and on the right side, you have just a sketch that explains by these pictures the entire mission itself to get to the moon and then the samples back from the moon. So again, they completed the collection of samples that has been brought back by the Apollo program. Of course, on one side you have 340 kilograms, on the other you have only hundreds of grams. But most of the studies you can do on less than millimeter scale samples. So they distributed samples in many institutions, and just because the samples are either collected in different places or at different depths, and that's unique. No one has ever collected samples so deep in the regolith. They contribute very efficiently to all the discoveries that has been made through the lunar samples to fundamental stuff like the origin of the moon, the way the moon has been formed out of material created in a disk formed by an impact on the Earth, and so on and so on. And I know that all that will be explained during this marathon here. So I don't need to talk about that. I will just finish saying this mission was the last Soviet mission in '76. As you know, Soviet Union disappeared, something like 15 years later. And the Russian mission now decided to go back to the moon. And interestingly, they decided to continue the same numbering. So the next mission will be Luna 25, although it will be long after the very first one. And these are the first Luna 25 should go, if everything goes fine, only in a few months ahead of us. It would be a lander, and this time they would like to go close to the South Pole, because we know that close to the South Pole, there are places in craters that probably never had any illumination. And we think that that could be a reason for random grains with water, ice, to be kept as such there. And there might be some still present, some water in that form, ice residue, to be possibly to be explored and used for future missions. So that's why now both the Chinese on one side and the Russians would like to explore the South Pole. And that will be followed by 3 others, 26, 7, and 8. And you have here the expected launch date, which is 24 for an orbiter. 27, they would go back with a lander and a rover. And that's a mission made in cooperation between Russia and India. And if everything goes fine in 28, which is not that far away, it would be in 27, they should go close to that place, close to the South Pole, Aitken Crater, and to get a sample return mission as they did more than almost 50 years ago. So to finish with, they were really pioneer people in exploration of space, in launching the space exploration era. And because that has been done on the moon, for the moon, it has been also fundamental and fantastic in a sense, because it was entirely robotic. That's what Korolev wanted. Korolev always thought that man would send automated probe everywhere in the solar system and men around the Earth. So that's why the Soviets built a lot of space stations. They wanted to know whether or not human beings could live and work around the Earth. But they considered that the best would be to send robot automated probes outside the Earth environment. And that's what they started with the moon. And what they did is really unique. No one ever did the same. Those who are now close to resume what they have been doing are the Chinese. As you might remember, the Chinese made a lander on the far side 2 years ago. And then afterward, they planned to do, and they did that once with Chang'e 5, a return sample from the near side. They did that a few months ago. And they plan now to send, probably in 2 years ahead of us, a probe that will land on the far side to make a 2-meter depth core again on the far side of the moon. And that could be just before the Russians do that again, possibly in cooperation with others, Europeans included. Okay, I will finish here. Thank you very much. I do not know what the time is, but I guess I don't know. You will tell me. Thank you.